Okay, so the idea of a limit is the intended output of a function, and that sounds kind of technical. Let's talk about it in a slightly different way. So we have Jenna, we have Peyton. They decided that they want to meet at, let's say they're going to meet at Burger Local. So Jenna's over here, she makes the drive, she goes to Burger Local. Peyton's over here, she makes the drive, she goes to Burger Local as well. And if I made this as a limit problem, I would say like the limit as time goes on of their two functions is the same thing. Their limit is equal to Burger Local. That's where they end up. Now, different example. Let's say that Jen and Peyton say they want to meet at TGI Fridays. So they know where that's at. Jenna drives there. Peyton drives there. But what's going to happen once they get to TGI Fridays? Do you know? It's not there anymore, right? It's like it went out of business a while ago. But even though it's not there, even though there's a new place in there now, they still met at the same place. So their limit exists. The limit is where they are coming together, where they're meeting at. So even if it doesn't exist where they're trying to get to, if they're both ending up the same location or trying to get to the same spot, the limit still exists. The limit is that value. Here's a different example. Let's say that Jen and Peyton decide they both want to meet at Starbucks. When I say Starbucks, what Starbucks are you thinking of? The one on Randall by like Eaglebrook? Yeah. Okay. So Jenna is going towards Eaglebrook. Peyton, what Starbucks are you thinking of? The one by Meyer. So she's driving here. Thanks for saying it that way. So she's going to the Starbucks in front of Meyer. Now they're both trying to get to Starbucks. They misunderstood each other. So as I said, the limit as the time is passing on in this one, like, are they both going to the same location? The answer is no. If I look at from Jenna's side and from Peyton's side, they're not going towards the same place. So the answer to this limit would be the limit does not exist. Because the two functions are going to separate spots, that's when the limit does not exist. Like, so from Mean Girls, when they say the limit does not exist, that's what they're talking about. Like the intended result of where they're heading from the left and from the right. If it doesn't match up, then the limit does not exist. Remember, it's okay in that first example of going, or the second example, going to TGI Fridays. It doesn't matter if like there's nothing actually at that point. If from both sides you're going towards the same spot, the limit exists. It's where you are intending to go to. So let's get into some examples. First of all, the definition for a limit. What is a limit? A limit is the intended value of a function. And I think that's one of the best definitions I've seen for a limit. And it might seem kind of like vague, like, well, how am I supposed to know the intent of this function or this graph or this table? Well, you look at it and you make the best estimation that you can sometimes. And a lot of these are going to be multiple choice. You have to make a prediction based off of what you see happening with what you're given. Typical example, first one, it says the function g, so here is that function g drawn out in blue, is defined for all real numbers as set at x equals 5. So if you notice on the graph, when x equals 5, there is a hole in the graph. There is this hole in the graph. The question that we're trying to answer here is what is the limit of this function g of x as x approaches 5? And we can phrase this in a few different ways. I could say the limit as x approaches 5 of g of x, or I could say, what is the limit of g of x as x approaches 5? It means the same thing. Don't get tied up like, how am I supposed to like actually say this? But we're saying for this function g, as the x values are getting closer to 5, what are the output or y values? So look at this. As the x values are getting closer to 5, so I'm drawing in all these little green segments, like where I'm like on the graph, what are the y values getting closer and closer to? So here my x is getting closer to 5. The y values are getting closer and closer to -2. And then if I look at it from the other side, as these x values from the right are getting closer to 5, these y values are also getting closer to -2. So the answer to this question, what is the limit as x approaches 5? The answer is -2. Even though there's a hole there, I can see from both sides of this graph, the function is intending, it's headed towards an output of -2 or y value of -2. So yes, this limit exists. Even though g of 5 doesn't exist, the limit does exist. To the right, new example. So that was a graphing example. Now we have a table example. And this is something you would see like in a typical AP calculus class. You'll see a graphing example, then you'll see a table example, and then you might see like an actual function written out. It says the function g is defined over the real numbers. So that just means that g is a continuous function. Like there's a bunch of, like we could draw the entire graph and it would be okay. This table gives a few values of g, and we are asked, what is the limit as x approaches -2? So notice in the middle of this graph, we don't have an x value of -2 actually given to us, which is totally okay. If x at -2 is undefined, if we got some really weird number, none of that would really matter. We're just trying to see as these x values from the left, these x values that are slightly less than -2 get closer and closer to exactly -2, what's happening with the y values? And also, as the x values slightly bigger than -2, and because we're working with negative numbers here, this is bigger than -2. As these x values get closer and closer to -2, what's happening with these y values? Can you see how these y values are converging on something? How as those x values are getting closer and closer to -2, what are these y values getting closer and closer to? Like I can look at the trend, 8.97, 8.15, 8.03. And from the other side, 9.04, 8.23, 8.02. When we get close enough to x equals -2, what do you think the g of x value is going to be? Go ahead and turn to your friend, throw out your guess. What do you think this is going to be? Best guess, go ahead. Okay, so what do you think is the limit for this one? 8, right? These y values from both sides are getting closer and closer to 8, so the limit is 8. What if I had said 8.01? Would I have been wrong? No, that would have been a fine approximation, a reasonable estimate, but I think 8 is probably the most reasonable one. It seems like that would probably be what it's going towards. If it was multiple choice, you'd have one best answer then. Next one. The function f is defined for all real numbers. Great. So we have a filled in circle and an open circle. That's okay. And then the graph does what it's going to do. The question is down at the bottom. What is a reasonable estimate for the limit as x approaches -5 of f of x? So let me go ahead and draw this one out again. As x is approaching -5, what's happening to the y values? What are they getting closer and closer to? So here is x equals -5. And if I go to the graph, as these x values keep getting closer and closer to -5, what are their y values getting closer and closer to? 6. So from the left, the limit is approaching 6. But I also have to look at it from the right. And as these x values keep getting closer and closer to -5, what are these y values approaching? -4. So the limit from the left is 6. The limit from the right was -4. What do you think this limit's going to be? No limit. This is the limit does not exist. This is when somebody's going to Starbucks at Eaglebrook, someone's going to Starbucks at Meyer. The limit does not exist because they're going towards different things. We could say does not exist or abbreviate to DNE. This limit does not exist because they're not going towards the same thing. The two-sided limits have to be equal to each other. The two different sides of it have to be going towards the same number. They're not here, so the limit does not exist. Let me pause a second. Go ahead and read this next one. The question is, what is the limit as x approaches -1? Let's take a look at it. Okay, so here's the thoughts. When x equals -1, when x equals -1 or h of -1, what is h of -1 actually equal to? 4, right? That's what this dot up here is telling us. But from the left, as we are getting x values closer and closer to -1, And from the right, as these x values are getting closer and closer to -1, what are those two sides of the limit approaching for a y value? -3. So what is our limit? -3. So the limit exists. It is -3. That's just like the example of two people trying to go to a store that isn't there anymore. It doesn't matter if the store is not there. They're still ending up at the same spot. They're trending towards the same place. To throw you off. To make you think like, oh, it must be +4. No, it's like this is irrelevant. It's just a distractor. Like it's irrelevant as the limit goes, at least. Next one. This is a different notation. And you might be saying, like, that doesn't make any sense. The limit of f of x as x approaches +0, like, what does it mean 0 with a little positive sign right there? 0 isn't positive, 0 isn't negative. So what's the deal with that positive sign? Notice it is after the 0. It means from the positive side or from the right side. It's only a one-sided limit this time. So this is not just the limit as x approaches 0. It's the limit as x approaches 0 with numbers that are slightly bigger than 0. So as I look at this graph, do I need to look at those blue points or those orange points? Orange. This on the left doesn't matter. So from the right of 0, as x keeps getting closer and closer to 0, what is the f of x value getting closer and closer to? 7. So this limit is 7. It's only a one-sided limit. Usually one-sided limits do exist because they're generally trending towards something. I know it's at the very bottom of the screen. It's saying, what is the limit of h of x as x approaches -4 with a little positive sign after it? -4 from the right. So am I looking to the left or right of this vertical asymptote? To the right, -4 from the right. So as these x values keep getting closer and closer to -4, what are those y values trending towards? Well, there's a couple of ways I could think about this. Like, it's not clear. Like, there's no like specific integer that it's going towards. But if we were to keep going further, like what would be happening with this side of the graph? Up, 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 up. How high is it going to go? Right, all the way up. So there are two answers. One is not specific enough. You could say the limit does not exist. It does not exist as a real number. But more specific than that, how does it not exist? It exists because it's trending towards this concept of infinity. Infinity is not a number. Infinity is a concept. So what is this limit from the right? It's going up forever without bound. It is not existing as a real number, but it's infinity. Infinity is the best way to answer this. If there's multiple choice and infinity wasn't an answer, does not exist is an answer, that would be the best answer. It's an okay answer, but this is a more specific answer because it tells us how it fails to exist as a number because it's going up as opposed to down. All right, so the next one you're going to need, I'll show you my screen. There are 4 potential answers. There might be more than one correct answer. I'll put my screen up here a little bit bigger so you can see this as you read the questions on your own. All right, so letter A, the limit as x approaches -2 is equal to 6. So as I'm looking at the graph and tracing it from both sides, as x is approaching -2 from both sides, are they both trending towards 6? No, so it's not going to be letter A. Letter B, the limit as x approaches -2 with the minus sign, so -2 from the left, is that equal to 6? So now I'm only looking on the left side, and as these x values are getting closer and closer to -2, is the y value trending towards 6? What do we think? Yeah. Letter C, we might have more than one correct answer. The limit as x approaches 0 from the right doesn't exist. So if I'm looking at x getting closer and closer to 0, does it look like the y values are zeroing in on something? Like what output? 0. Bad pun, I said zeroing in, I didn't mean it that way. But yeah, as x is getting closer to 0 from the right, the y values are getting closer to 0. So letter C, does the limit exist? It actually does. So letter C could not be correct. And then D isn't correct because letter B worked. So letter B is our only correct answer for that one. All right, next question, and here it is. The limit as x approaches 3 of g of x is equal to 5. Which of these graphs agree with that statement? So we want the limit as x approaches 3 for this function g of x to be equal to 5. Which of those is going to work? I don't think I really need to zoom in a whole lot because you're not needing a bunch of detail on this one. So the limit as x approaches 3 equals 5. Each of those graphs is slightly different. For the first one, as the x values are getting closer to 3, is the y value getting closer to 5? It is. Even though there's a hole there, the limit still equals 5. For letter B, as x is getting closer to 3, is the y value getting closer and closer to 5? It is. There's a hole in the graph, and we have this filled in dot down here. That doesn't matter. The limit is still equal to 5. And letter C, as x is approaching 3 from the left and the right, and it is even continuous there, it goes right through that point. That one is true as well. All three of those have a limit as x approaches 3 being equal to 5. So again, I'm trying to show you like a wide variety of limit problems, just getting the concepts down. There's not a lot of calculations as you've seen so far. It's just interpreting graphs and interpreting tables. There will be a little bit later on where we have to do some kind of calculations, but not a whole lot. It's mostly just this concept of what does it mean to be a limit. So go ahead and read this one. So there's some function f of x, and it says that this table is accurate. I don't know what the equation actually is. And maybe you even notice that in each one of these tables, they all have the same point of 5.005 for x and f of x equals 6.012. They all have that. It's like these are the same from the same graphs, but which one of them is best in order to approximate the limit as x approaches 5? What you really need to pay attention to are the x values. So for this letter A, are these values from the right, are they getting closer and closer to x equals 5? I would say so. And then from the left, are these x values getting closer and closer to 5? What are they getting closer and closer to? -5. So it's kind of a trick right here. They even gave us when x equals 5 in the middle, but what they said is that as x is approaching 5 from the right, maybe we're doing something kind of like this. But then as x approaches -5, so they're showing us something all the way over here at -5, and those values are like getting huge negative numbers. Does that tell us what's happening as x approaches +5 from both sides? It doesn't. That table really isn't useful for us. I need to see x approaching 5 from both sides, and because all of these numbers were not getting closer and closer to +5, this is a worthless table. Look at letter B. This time, notice we don't have x equals 5 right in the middle. It's not given to us, but that's okay. It might not be there. But are these x values getting closer and closer to 5? And then from the other side, are these x values getting closer and closer to 5? Yeah, the x values are zeroing in on 5. I'm thinking this letter B looks pretty good. Letter C, these x values are getting closer and closer to 5 from the right side, but do we have any numbers that are slightly less than 5 and getting closer and closer to it? Unfortunately, we don't. So which one of these could we use to approximate this limit as x approaches 5? Be letter B. To go a little bit further with this question, what do you think this limit would be equal to? Miwash? So as we look at these x values getting closer and closer to 5, these x values getting closer and closer to 5, like what are these y values trending towards? And it's just an estimation. Grace? 6? I think 6 would be a logical guess. These are getting closer to 6. These y values are getting closer to 6. So I think that limit probably is 6, something pretty close to that. So here's another table, and we're saying that this is a reasonable table. This table does give us a good look at this one. What do you think is the limit as x approaches 5? I'm going to pause for a second, give you a chance to look at that. Doesn't matter. Go back to the very first example. It doesn't matter if TGI Fridays is there or not. It doesn't. So what I'm going to say is this middle doesn't matter. Like I really don't care what's happening right at that point. It could be a hole in the graph or it could actually be there. But as you're trending to x values closer to 5 that are slightly less than 5 and x values that are slightly bigger than 5 but getting closer to 5, what are those y values getting closer and closer to? 3.67, maybe 6.6. Maybe it's supposed to be 3.6 repeating, and we don't know for sure. We just need to give a reasonable estimate, and I think 3.67 would make sense. It doesn't, like this number in the middle is just to throw us off. Like, so if I were to graph this, here's x equals 5. From the left, the y values are getting closer and closer to 3.5. Actually, smaller, getting bigger. And then from the right, as x is approaching 5, these y values are getting closer and closer to 3.68. When x equals 5, the output is somewhere up there. That's what this point is. It's this like this outlier point, but the limit from both sides is that about 3.67. All right, go and read the next one. So what is the limit as x approaches -2? Notice from the table, these are x values getting closer to -2, slightly less than -2. What are these output values getting closer and closer to? 5. Okay, and then from the right, these x values are slightly bigger than -2. They're getting closer and closer to -2. But what are these y values getting closer and closer to? 7. So as far as the graph goes at -2, from the left, it looks like the y values are going towards +5. From the right, it looks like the y values are going towards 7. So what would you say the limit is here? Does not exist. It's not 5, it's not 7, it's not even 6. Neither of those are getting closer and closer to 6, even though 6 is between 5 and 7. The limit does not exist because they're both going towards different numbers. All right, try the next one. All right. Which of these answers doesn't make any sense? 0 doesn't make any sense. Like these y, like the x values are getting close to 0, but the outputs are not getting close to 0. What else doesn't make sense? 0.1 doesn't make sense. 2.75? Not really. 2.9? Yeah, they're getting closer, both sides, 2.9. I would say yes, that would be accurate. That it would be a pretty good prediction, a reasonable estimate. Next one, limit of f of x as x approaches -4 from the right. There is a little positive sign after that. What would be a reasonable estimate? Which matters here, the blue or the yellow? The yellow. -4 from the right, numbers that are slightly bigger than -4. And what are these y values approaching? -6. Does this 9 matter at all? No. Nor does the stuff coming at it from the other side. Answer would be -6. Next one. X approaching 6 with the little negative sign. What would be a reasonable estimate for that? All right, which colors don't matter here? Green, what else? Orange. X is approaching 6 from the left, slightly less than 6. So what is this limit going to be? -6. Imagine, though, like what if try it again. What if there's a double-sided limit and it said, what is the limit as x approaches 6? Then what would the answer have been? Does not exist because they're going towards different values. Okay. But it does have that negative sign, so here is our correct answer. All right, what I want you to do, this is day number